Good evening. Welcome to 21 Days of Code. Today we will be solving problem 746, minimum cost climbing stairs. On a staircase, the ith step has some non-negative cost. Once you pay the cost, you can either climb one or two steps. You need to find minimum cost to reach the top of the floor, and you can either start from step with index 0 or step with index 1. Taking this example, the problem wants us to find the minimum cost to reach the top of the floor, selecting either index 0 or index 1 as the starting point, and keep climbing the stairs until we reach the top while minimizing the cost along the way. So let's start. A common approach which comes to the mind is, let's take the minimum of the two steps and keep moving up the stairs. Let's see if it works. Taking the minimum of 1 and 100 will give us 1. So we are on this stair, then our cost is 1. Taking the minimum of the next two, 101, we get 1 as minimum, so we'll move here and the cost is plus 1. Taking the minimum of the next two stairs, as they are equal, we will be moving one extra step. Here, we will be adding 1. Taking the minimum of next two, here, we'll be adding 1. Taking the minimum of next two, we'll move here because 1 is less than 100, add 1. Taking the minimum of next two, we will be here and then we will reach the top. So adding 1 again, 1, 2, 3, 4, 5 and 6. The output is 6. See, the output is 6. So this approach works, but not in certain cases. Like, let's take the minimum of these two. It's 0. So we are here. Taking the minimum of next two, we see that 1 is minimum, so we are here. So first the cost was 0 plus 1. Then we can take the minimum of these two as they are same. We will move here and then we are at the top. But the cost here comes out to be 3. But let's see, if we were to move to 0 and then 2 and then to the top, our minimum cost would be 2. So this approach does not work every time. We will be using something called dynamic programming here. If you are not familiar with it, don't worry, you can check out the link in the description box. And also, you don't really need to have a hand on dynamic programming to solve this problem. Let's solve this problem using DP. In DP, we will be saving the previous states of the array to get to our current state. Let's see this example. First, as we are always going to start from index 0 and 1, we will save these states as it is. That is 1 and 100 for 0 and 1. At index 2, we will save the current state plus minimum of the previous two states, because we can only have either one move or two move. So 1 plus minimum of 1 and 100, 2. Same for the third, 1 plus minimum of 102, 3. Same, 1 plus minimum of 2 and 3, that will be 3. So what we are doing here is, we are on a state and we want to see from which state we can reach to the current state so that our cost is minimum. If we keep repeating this process, we will reach to the top with the minimum cost possible. Let's continue this. For 100, we will use 100 plus the minimum of previous two, that will be 103. For 1 plus minimum of these two, that is 4. 1 plus minimum of these two, that will be 5. 100 plus minimum of these two, that will be 104. And then 1 plus minimum of 5 and 104, that will be 1 plus 5 and 6. And then our answer will be minimum of these last two states. That is, we can reach to the top from either in one step or in two steps. So we will be going to the last step and then going to the top. So answer will be 6. Let's try this approach in the question we were having some trouble in. For 0, 1, 2, 2, our first and second state will be 0 and 1. Then for this we'll be using 2 plus minimum of 0 and 1, that will be 2. And here 2 plus minimum of 1 and 2, that will be 2 plus 1, that is 3. So answer will be minimum of 2 and 3, and that will be 2. So we get our correct answer. Now let's code this approach. First, initialize a variable to store the size. Second, initialize a DP array to store the states. Store the first and the second state as they are always going to remain the same. Initialize a for loop to store the states of the remaining array. That is dpi, the ith state will be equal to the cost at the ith step plus minimum of the previous two states. And then we return the minimum of the last two states. That is, we get the answer to our minimum cost. We can also do this without the DP array. Try to code the constant space approach yourself.